So in this video, I'm going to show you the solutions to solve tutorial 10. Okay, the first questions, let's look at the first questions. The first question is asking you to find the area bounded by the curves y equals to 3x squared minus 2x and the line y equals to 1 minus 4x. So in this question is quite easy because the graph for these two functions are given in the questions. So let's look how is the graph look like. So this is y-axis, this is x-axis. So the curve is look like this. And the line is here. This is the line. Sorry, my line is not so straight. So this is actually the curves y equals to 3x squared minus 2x. And this is the line y equals to 1 minus 4x. So as you can see from the graph, there are two intersection points. One is here. The other one is here. Okay, so you have to find these two intersection points. So how are you going to find these two intersection points? So we make 3x squared minus 2x equivalent to 1 minus 4x. And then we solve these equations, simplified it, becomes a quadratic equations. So this is a quadratic equations minus 1. Okay, and then you can factorize it. So when you factorize it, you get this, and then there are 2 points. One is x equals to 1 over 3. The other one is x equals to negative 1. So when x is 1 over 3, y is negative 1 over 3. Okay, you sub 1 over 3 into the formula, you get this, y equals to 1, negative 1 over 3. And when x is negative 1, y is 5. Okay, so these are the points. These are the points. So this is negative 1, 5, and this point is 1 over 3 and negative 1 over 3. So question, don't forget the question is asking you to find the area bounded by these two functions. So you have to continue to find this. So which function always give you the larger value? These equations, the line function always give you the larger value. Because as you can see from the graph, it is always on top of the curve at the intersection point. And between the range when x is negative 1 and x equals to 1 over 3, these functions it always give you the smaller value. So we form this. We continue to find the area. We form the integral. Okay, by referring this, we can actually cut a small piece of dx. Take a small dx from negative 1 to 1 over 3. So from negative 1 to 1 over 3, the larger value is the line equation. And the smaller value is the quadratic equation. 3x squared minus 2x. Okay, so this is actually the length, and dx is actually this is length and this is width. So length by width from -1 to 1/3 to 1/3, and then you solve this integral. You solve the integral, you're able to find the area of the bounded region. Okay, so now you can integrate it, and you get this. Calculate from range -1 to 1/3, and the answer is 32/27. So if the question doesn't give you the unit of the radius, you can just put unit square. Okay, so this is the solution for the first question in tutorial 10. Okay, now we continue with question 2. So question 2 is asking us to find the area of the region in the first quadrant bounded by the line y equals to x, the line x equals to 2, curve y equals to 1/x squared, and x-axis. So let's plot the graph first. So for the first quadrant, this is the first quadrant, x-axis, y-axis. So the line y equals to x, this is line y equals to x. And then the line x equals to 2. This is line x equals to 2. The curve y equals to 1/x squared. So if you don't know, you can assume any value for x and then plot this function. So the graph for y equals to 1/x squared look like this. And also the x-axis, so bounded by this region. So you see there's actually one intersection point here. So how are we going to find this intersection point? So we make this intersection point is come from the line y equals to x and the curve y equals to 1/x squared. So we make 1/x squared equals to x, and then we get x cubed equals to 1, so x equals to 1. So the intersection point here is x equals to 1. So you see, we can actually form two integrals to find first integral to define area 1 and second one to find area 2. So how do we form integral to find area 1? Area 1 is from 0 to 1 with dx width, and the length is this. The length is y equals to x. So the first integral could help us to find a1. So you solve the integral, you get this. Then find the range of it. So the answer is half unit square. How about area 2? So now let's form the integral for area 2. Area 2 is from x. Area 2 is from x equals to 1 to x equals to 2. So from 1 to 2, now the bounded region is 1x squared dx. So solve the second integral, you will get this. Okay, and then found the solution for it, you get so here you get this half unit square. So the total area is equals to A1 plus A2 equals to 1 unit square. So these are the total area for the bounded regions. Okay, we continue question 3. So now question 3 is asked you to find the volume generated, is to find the volume. So you have to form an integral to find the volume. So the bounded area is for the curve y equals to square root x, and the x-axis and the line x equals to 4 and revolve around the y-axis. So let's plot the graph first. So we have this y equals to square root x. So this is the curve y equals to square root x, and this is x equals to 4, and then we have x-axis, and this whole piece of area is going to revolve around the y-axis. So when it revolves around the y-axis, you actually form a cylinder like this. If you look at the side way, you form a cylinder like this, and there's a hollow here. So these are the solid part. The hollow is here. So in this cylinder, what is the outer radius? So this is the outer radius, and this is the inner radius. So the outer radius is constant. So what is the outer radius? R out is constant, equals to 4. How about the inner radius? Inner radius is vary with this function y equals to square root x. So this is inner radius. Inner radius y equals to square root x. So now let's take a small piece of this. So when we take a small piece, we cut this whole piece horizontally with small piece of dy. So if you want to denote the integral with dy, if you want to find the volume with the integral dy, so we know that the volume of the cylinder with a hollow inside is pi outer radius square minus inner radius square. If you form the integral in terms of dy, you have to make the functions you have to make r out as a function of y, r in as a function of y as well. So here we got this. So we have to make outer radius functions of, so r out is 4 square, and r in is, we have to make it functions of y. So from here, x is equals to y squared. So r in is equals to y squared, and then you have to square this once again. So solving this integral will give you the solutions of the volume. And don't forget, what is the range for dy? Dy is from 0 to here. Find the intersection point here. You're able to get this one is 2. This is 2. So from 0 to 2, this is 16 minus y to the power of 4 dy. So solving this integral will lead you to find the volume. So the volume is this unit cube. Okay, now let's look at the last question. The last question is also ask you to find the volume generated by the revolving area enclosed by a triangle with vertices. So the vertices are given for the triangle. So we have point 1, 0, we have point 1, 1, and we have another point 2, 1. So these 3 points form a triangle area. Okay, so this piece of area is going to revolve around the y-axis. Okay, this area is going to revolve around the y-axis. So when you revolve around the y-axis, the side you're able to, the side of the object look like this. But if you look at the top side of it, there is actually a hollow, and this is the solid object, and there is a hollow like this. So now you can also form an integral to find this volume. So which is the outer radius? This is the outer radius. So the outer radius is varying and the inner radius is constant. What is the inner radius? Inner radius is 1. So can you find outer radius? Yes. Can you find the functions to describe outer radius? This is outer radius. So we have 2 points. So we can find the linear equation from these 2 points, 2, 1 and 1, 0, and we're able to get these equations. Y equals to x minus 1. So same thing, we cut these objects horizontally with a small piece of dy. So we're summing out this dy from 0 to 1. So you form the integral dy from 0 to 1 with pi. This is the volume. So outer radius square minus inner radius square. Because you are making the integral with dy, so you have to find outer r out is a functions of y. So you have to rearrange this. So x is equal to y plus 1. So outer radius is y. Outer radius is y plus 1 square minus inner radius is 1. So this is this is y. So minus 1 square dy. So solving this integral will make you to find the volume. Okay, and then we continue to solve the integral. Zero to 1. The answer is this unit cube.